Hello, in this video we will talk about the determinant. So first we will prove that either you take the determinant of the transpose or you take the determinant of A, you will get the same result. Here is the proof. So we will do proof by two different methods. So first of all, I will do the proof for 2 by 2 matrices. Okay. So let A is 2 by 2 matrix A11, A12, A21, A22. Then we have to prove that the determinant of A is the same as determinant of AT. Okay, since this is A, so we need AT also. Since this is the first row, I will make it first column. A11, A12. This is the second row, I will make it second column, A21 and A22. I have to prove that the determinant of this and the determinant of this are same because this is A and this is A transpose. This is what the claim is. Look at the determinant of A first. Determinant of A is obtained by just multiplying these two things. A11, A22 minus multiplying these two things. A21, A12. So this is determinant of A. Now we take the determinant of A transpose. The determinant of A transpose will be obtained by multiplying these two things first. A11, A22 minus multiply these two things. A12, A21. But if you check that both are giving you the same answer, A11, A22, the first term is the same. And the second term is A21 here and A12 here. Okay. So since both terms are the same, so we will say that determinant of A is equal to determinant of A transpose. Hence this is proved. Since this proof is for 2 by 2 matrices. Now let's do for 3 by 3 matrices. So consider a 3 by 3 matrix. A general 3 by 3 matrix is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the general 3 by 3 matrix. I have to prove that the determinant of this one is equal to the determinant of A transpose. So I need its transpose first. For the transpose, I need to write this row as a first column, A11, A12, A13. And now this row as a second column, A21, A22, A23, and this as a third column, A31, A32, A33. Okay. Now I will prove that their determinant is same. First I will find the determinant of this and then I will find the determinant of this. Okay. So for 3 by 3 matrices, we cannot apply this direct formula. We have done in 2 by 2 matrices. In 2 by 2 matrices, we just multiply these things minus multiply these things. But here we have 3 different columns and 3 different rows. We cannot do this and we cannot do this because these things will be left. So we have to consider all of these entries. So what we will do, we will choose any row or any column For example, if I choose the first row here, I will expand the determinant along the first row. It depends up to you. Either you choose the first row, or you choose the second row, or you choose the third row, or you choose the first column, you choose the second column, or the third column. You have 6 different options to evaluate 3 by 3 determinant. Okay, but the most important thing is that whatever option you choose, you will end up with the same result, because determinant will always be unchanged. Okay, look, in order to find a determinant of A, I will choose the first row to expand the determinant. And in order to find the determinant of AT, I will choose the first column to expand the determinant. Why I am doing this? Since the first row of A is the same as the first column of A transpose. Because of construction, because A transpose is obtained by converting rows into columns. So therefore, since this first row is the same as this first column, and I have to prove that their determinants are same, therefore I will expand the determinant of A along the first row and determinant of A transpose along the first column. Make sense? This is my choice. So expand the determinant of A by first row. Okay, first row has 3 different elements, so corresponding to each element I have a cofactor. Okay, so corresponding to A11 I have a cofactor which is negative 1 to the power 1 plus 1 A11, and if I forget about this row and this column, I will have A22, A32, A23, A33. Okay, this will I left. Okay, now I will write another cofactor, because this is the row I have done with this. Now I will do with this. Okay, A12 means minus 1 to the power 1 plus 2 A12, and a determinant of 2 by 2 matrix. By forgetting about this column and this row, I will have A21, A31, then A23, A33. Okay, now I have done with this element also. The first 2 elements are done. Now I have to do with this element. So plus minus 1 to the power 1 plus 3 A13. Then I will write the determinant of 2 by 2 matrix by forgetting about this row and this column. I have only this thing, A21, A22, A31, A32. Okay? Yes. So I have evaluated the determinant of A because I have evaluated for each entry of the first row. You can do the same thing for row 2, row 3, or any row. You will end up with the same result. So this is the determinant of A. Now, if you want to simplify it, minus 1 to the power 1 plus 1. Okay, look, minus 1 to the power 1 plus 1 is minus 1 to the power 2. This is minus 1 to the power 3. This is minus 1 to the power 4. And there is a rule, minus 1 to the power even is plus, and minus 1 to the power odd number is minus. Okay, this is the rule. So if I write it properly, it will be everything, but here I will write only plus A11, Okay, A11 and then this thing. Okay, I'll just copy. Okay, and then this thing is minus 1 to the power odd number because 3 is odd number, so this is just minus. Okay, so minus 1 to the power even is plus and minus 1 to the power odd is minus. And then I will do with this thing, since this thing is minus 1 to the power even, which is 4, so this is just plus. Okay, and then I will write these things as it is. So this is the answer of the first determinant. Okay, determinant of A. This is the determinant of A. So here no need to write plus, okay, because it's the first term, it's always plus. Now let's look at the determinant of A transpose. And I told you, since I have expanded the determinant of A along the first row, and this first row is equal to this first column, so therefore I will expand the determinant of A transpose along the first column. Okay, so along the first column, the first entry is A11. I will write minus 1 to the power 1 plus 1 A11, and then forget about this, I will have this thing which is the same as this thing. Okay, because this is A22, A23, A32 and up to so on. You can check, these things are the same. Plus minus 1 to the power, because next I will go with this element, A12. So I will write minus 1 to the power 1 plus 2 A12, and then I'll forget about this, I will have these two and these two entries left, A21, A31, A21, A31, and A23, A33. Make sense? Now I have the next element. The next element is this one in this column. So I will write the cofactor along this based on this element. This is minus 1 to the power 1 plus 3, minus 1 to the power 1 plus 3, A13, and then if I forget about this, I will have only these elements left. Okay, again, minus 1 to the power even number is plus, minus 1 to the power odd number is minus, minus 1 to the power even number is plus. So what will I write? Minus 1 to the power even number is plus, so I will just write the first entry as it is, because this is just plus and the first entry is always plus, so there no problem. In order to write the second entry, I will copy this entry. Since minus 1 to the power odd number is minus, so here I will write minus. Okay, and here I will write just plus because it is minus 1 to the power 4. So it is just plus, so I will just write plus A something. So this is determinant of A transpose. Now look, determinant of A transpose and the determinant of A. What's the difference between them? The first entry is the same. Okay, we have to prove that everything is equal. First entry is the same. Look at the second entry, it is minus A12 minus A12. It is also the same. Look at this. A21, A23. A21, A23 is the column here. There it was row and here it is column. And the second row is the second column here. Look. Since they are 2 by 2 matrices, this is also 2 by 2 matrices. So for 2 by 2 matrices, I have proved that if I take the transpose of this matrix, or I take the if I take the determinant of this matrix, or I take the determinant of its transpose, which is here, I will get the same answer. So this thing and this thing are the same because they are transpose of each other and we are evaluating the determinant, okay? So they are the same. Similarly, look at the third element, which is A13. Here it is also A13. Again, the first row here is the first column here, okay? Second row is the second column here. So both are again transpose of each other and we are evaluating the determinants, so they are equal, okay? So this is the explanation. So I can write that determinant of A is equal to determinant of A transpose because all of the terms are same. This is same with this because both are the transpose of each other and we are evaluating the determinant. The determinant is the same for both, okay? For 2 by 2 matrices, and here is the proof for 2 by 2 matrices. And this is done.